Thanks for watching my presentation on how we can estimate the ambient noise spectrum from the synchrophasor measurements containing both ambient noise and forced oscillations. This work was published in the IEEE Transactions on Power System by me and Professor John Pierre from the University of Wyoming. So why the power industry is interested in estimating the ambient noise spectrum? It is because of the ambient noise carries core dynamic signatures of the power system in its spectrum, and it allows us to directly estimate the electromechanical modes from the ambient system measurements. On the left plot, you can see the ambient noise spectrum shows the peaks due to the dominant electromechanical modes of the wake system. The figure on the right shows continuous monitoring of the modes from ambient synchrophasor measurements. Here is an example of ambient measurements from the wake system. Around the 10th hour, there are forced oscillations which are not obvious in the time domain plot, but they are easily seen in the frequency domain plot. In this plot, we see that there is a forced oscillation near zero point 0.4 Hz, which is very close to the north-south mode B of the wake system. Its third harmonic at 1.2 Hz is very small. Also, there is another forced oscillation near 1.42 Hz. So, without the knowledge of the ongoing forced oscillation, the peak near zero point 0.4 Hz may mislead us by telling us that this is a dangerously low damped activity of the north-south mode B. If we model the synchrophasor measurements as ambient noise plus forced oscillation, we can come up with a complex valued regression model through a spectral and statistical analysis. Based on the model, we can formulate an estimator that can reduce the bias due to the forced oscillations in the ambient noise spectrum. This plot shows true ambient noise spectrum and estimated spectrum using Welsh periodogram method and the proposed method. Welsh method does not allow separable estimation of the ambient noise spectrum, and the narrow peak due to the forced oscillation at 0.37 Hz may seem a dangerously low damped model activity. The proposed method could successfully reduce the bias due to the forced oscillation in the ambient noise spectrum. This slide shows the estimator's performance, and it shows that its variance matches the theoretical result, and the variance is less than that of Welsh estimate. This result shows the ambient noise spectrum estimated from real-world data, and the bias due to the forced oscillation near 0.4 Hz, which is very close to the north-south mode B of the wake system, was successfully reduced by the estimator. Once again, the estimator has lower variance than the Welsh estimate. In summary, the estimator can successfully estimate the ambient noise spectrum from the synchrophasor measurements containing both ambient noise and forced oscillation using only synchrophasor measurements. We would like to thank BPA for their data and Professor Dan Tranowski for the use of Minimac model. Thanks for watching my presentation.